See here, this current source is converted into voltage source. Current source parallel to R. It's converted into voltage source series with R. Okay, see here HFP, RC, IB series with RC. Then you have the CR, CR, and CR. So in the output side, I am assuming the currents I1, I2, I3, and I'm writing the KVL equations. So I1 into RC plus R plus 1 by j omega C minus I2 R equal to minus HFP RC into IB. And second loop, there is no voltage source, so it is equal to 0. Third loop, there is no voltage source, so it is equal to 0. So I get three equations. And for simplicity, I'm assuming alpha equal to 1 by omega RC and K is equal to RC by R. So wherever I see 1 by omega RC, I replace it by alpha. And wherever I have RC by R, I replace it by small k. So take the last equation, equation number 3, and find what is I2 in terms of I3. You get I2 equal to I3 into 2 minus J alpha. What is alpha? 1 by omega RC. So this derivation completely we derived in the class. So here we are just going to see the overview of it. So you can derive the derivation, whatever we have seen in the class in your notes. So we have derived every step in the class. Okay. Now take the second equation, right? What is I1 in terms of I3? So I1 equal to I3 into 3 minus alpha square minus 4j alpha. Now substitute everything in equation number 1. And you get this thing. I3 by IB equal to this term, you get minus HFE K divided by real part minus J into imaginary part. And you see the equation is very simple and everything in terms of K alpha. Only you have everything in terms of K and alpha. For finding the frequency of oscillation, equate the imaginary term to 0 and put omega equal to omega naught. So imaginary term, you see 6 plus 4k into alpha minus alpha cube. So equate that to 0 or alpha square equal to 6 plus 4k. And what is alpha? 1 by omega CR. Here it is 1 by omega naught RC. And if you replace that and find F naught is going to be 1 by 2 pi RC into root of 6 plus 4k. And K is going to be RC by R. R is your collector resistance, RC is your collector resistance, and R is the resistance which is available in the feedback path of your RC phase shift oscillator. So now we have equated the imaginary term to 0. So now the imaginary term will be 0. Now take the real term. So I3 by IB equal to minus HFB K by 1 plus 3K minus 5 plus K into alpha square. Alpha square is 6 plus 4K. Substitute alpha square equal to 6 plus 4K here. If you substitute, you will get this expression. I3 by IB equal to HFB K by 4K square plus 23K plus 29. See, I3 is output current, is input current. For oscillation, the gain should be more than 1. Only when the gain is more than 1, the oscillation will take place. So I3 by IB greater than 1, or I can get HFE K greater than 4K square plus 23K plus 29, or divide by K on both sides. So HFE is greater than 4K plus 23 plus 29 by K. This is the condition for gain. So the minimum gain, the gain of the amplifier should satisfy this condition. And K, it is ratio of RC by R. So to determine what is the minimum value of K. So if you want to find the minimum value, differentiate this with respect to K and equate that to 0. So differentiate HFE with respect to K. So differentiation of 4K is 4. Differentiation of 23 is 0. Differentiation of 29 by K is minus 29 by K square equal to 0. So equate, so 4K square equal 29. K square equal 29 by 4, or K is equal to square root of 29 by 4. So the value comes out to be 2.7. Substitute this value of K here. Substitute K is equal to 2.7 in this equation. So you get HFE greater than 4 into 2.7 plus 23 plus 29 by 2.7. So you get the answer as 44.5. So from this, we can conclude that for the transistor to provide sustained oscillations, the minimum gain must be at least 45. At least means greater than or equal to 45 for providing sustained oscillations. Otherwise, this circuit will not generate sustained oscillations. Okay, so ensure that the beta value for the transistor is going to be 44.5. So that is the condition what you have for RC phase shift This is a very, very important part B question. And we have to derive the expression for F naught and the condition for minimum gain of the transistor, HFE minimum, which is 44.5.